Okay, 1.5 notes. We're going to learn how to take one formula and rewrite it in another form to solve for a different variable. Now we're also going to do application problems. So why is it important to be able to manipulate equations and formulas to isolate a specific variable? Well, let's take an example. Interest equals principal times rate times time. You may remember this from Algebra 1. So in a formula like this, if you're solving for interest and you plug in the other three variables, you've got your answer. But if you're solving for rate and you plug in all your numbers, you can do that and then crunch all the numbers. Or you can rewrite this saying, I want to solve this for R, which means I need to get rid of the P and the T. And how are they attached? By multiplication, which I undo by division. And now what happens is I get a new formula. Rate is equal to interest divided by principal times time. Looks like I'm drawing Chinese characters. Rate is equal to interest divided by principal times time. And now, when I plug my numbers in, I have less movement to do, and I can just crunch them. Now, it's not a big deal when you only have one to do, but it helps when you have multiple problems. So let's say you were solving 10 problems for rate, and another 10 problems for principal, and another 10 for time. Every time you plug the numbers in, you have to crunch the numbers and do all kinds of moving around. Whereas if you rewrite the formula before you start each set of problems, then everything's right in its proper place. So it's not a necessity, but it can help to make things run smoother. So I would suggest, like this one, I'm solving for A. So I want to get rid of everything. Now, there are two things attached to the A. The 2 by multiplication, and the 4, no, not subtraction, by addition. This is really a plus 4. Remember, I could also write this as negative 2a plus 4 equals 10. And it might be more clear to you to get rid of the 4 first, but by subtraction. So either way, no matter which way you write it, you're going to subtract 4 from both sides and get negative 2a is equal to 6. Then you divide by negative 2, and you're going to get a equals negative 3. Well, that was just solving for the variable, okay? But the same concepts go when you're manipulating and changing formulas. So, example 1 here, solve for y. You might think about this and remember Algebra 1 and even geometry when you had to put things in slope-intercept form. Y equals mx plus b. Remember that? Y equals mx plus b. Slope, now come in handy here again, and this is the y-intercept. Well, we have to get y by itself, so what do? We move the 4x over. Now, do not say 10 minus 4x is 6x. These do not combine. Common mistake, but that doesn't happen. We get negative 2y is equal to negative 4x plus 10. It's customary just to put the variable first. And now I divide everything by negative 2. Now, as opposed to the previous problem, I'm not going to get an answer because this equation had 2 different variables. I'm just going to get a different looking equation than the one I started with. They are equivalent to one another, they're just in different forms. Number 2, again, I circle my y, and I'm going to move the 3x. Cancel. I'm left with 1/2 y equals negative 3x plus 7. But I don't want a 1/2 y, I want a whole y, which means I need to double this. Also known as multiplying by the reciprocal, 2 over 1. Whenever there is a coefficient of your variable that is a fraction, you multiply by the flip, or the reciprocal. So I'm going to multiply this whole side by a 2. and then distribute it in. So this cancels, give me y equals negative 6x plus 14. Again, same equation, just in a different format. So number 3 should look familiar for that. Interest equals principal times rate times time. Solve for P. Just like we did upstairs in the first problem, I'm going to look at what's attached. Well, the R and T by multiplication. And I can get rid of these both at the same time. And I solve and get P equals interest divided by rate times time. It doesn't matter in what order. Okay, I had to look that one up because for some reason the rest of it didn't transfer into this new document. So, again, I'm solving for y. Well, there's a lot going on. First, this is all tied together by a bunch of multiplication and division. So again, I want to get rid of the furthest thing away, which is the c. And since it's being subtracted, I'm going to add it. A plus c is equal to x plus y over 2. Now, I need to get rid of the x, but first I need to get rid of this 2. And I'm going to do that by multiplication, because that cancels. Which is going to be over here. Don't forget that it gets distributed to the a and c. Now, I can leave it like this, or I can actually distribute it. Okay? 2a plus 2c is equal to x plus y. Subtract x. So I'm going to get y is equal to 2a plus 2c minus x. And that's my answer right there. It would not have been a big deal if you left it like this. That would also be an appropriate answer. Number 5. Y equals bx squared plus cx minus 5 for b. So here's my b, that's what I'm solving for. I'm going to first off just get rid of both of these at the same time. I'm going to minus cx and add 5, because I can do that. I can do it in 2 steps also, but since I'm just moving it over, there's nothing really to work with, it's not a big deal. So on this side, I'm going to get y minus cx plus 5 is equal to bx squared. Now, the x squared is attached by multiplication, so I'm just going to divide by x squared. Cancels. I get b equal to y minus cx plus 5 over x squared. And that's finished. Okay, 4m minus 3n equals 7m plus 6n. Well, first off, I need to solve for m, but there's 2m. So what I'm going to do is I'm going to combine like terms. I'm going to move this 7m over here. And I can do it in 2 steps, or I can move this 3n to the right. It's up to you what you're comfortable with. 2 steps is fine. Over here I get 4 minus 7 is negative 3m's. My n's cancel. On the right side, my m's cancel, and I get 6 plus 3 is 9n. Now, I want to solve for m, so I'm going to divide by negative 3. Cancels, giving me m equals, I could write 9n over negative 3, but think about the fact that this is going to cancel. Don't forget your negative. 9 divided by negative 3 is negative 3n. And that's what m is equal to. Okay, now some application problems. Okay, sorry, the formula again did not transfer over. I know it is in your packets. Okay, changes to a gas at negative 109 degrees Fahrenheit. And the formula is 9/5 times Celsius degrees plus 32. Okay, there's 2 ways I could do this. I could put the 190 degrees in right here for the Fahrenheit and then solve. Or I could do what we've been doing and solve for C, which I'm going to do that right now. So I'm going to first subtract 32 and get F minus 32 equals 9/5 my Celsius temperature. Now, to get rid of the 9/5, remember, it is a fractional coefficient. I'm going to multiply by 5/9, which cancels, which means I need to multiply this by 5/9. So my formula is C is equal to 5/9 of my Fahrenheit minus 32 degrees. So now I just plug the 109 in here, and I'm going to get C is equal to 5/9 of negative 109 minus 32, which is negative 141. And now I'm going to multiply by 5 and then divide by 9. So negative 141 times 5 divided by 9. That's negative 78.3 degrees repeating Celsius. And since it says round to the nearest degree, we're going to say 78 degrees Celsius is our answer. Okay, number 8. You buy a used car with 67 to 150 on the odometer. You expect the car to drive it 12,500 each year. How many years will it take to reach 150,000 miles? Well, first off, we have to find out how many miles are between here and here. So your goal is 150,000. You're starting at 67, 150. I don't know why. There's a minus sign there. 67, 150. We're going to subtract those to find out how many miles are left. That means you have 82,850 miles until your target goal. If you're going to go 12,500 per year, that means division. We're going to take our answer and divide by 12,500. That's going to be 6.628. So approximately 6.5 years. A little over that. Number 9. The sum of the lengths of two sides of a triangle is greater than the length of the third side. If a certain triangle has lengths of 6 and 8, write 3 inequalities using the given information, then describe the possible lengths of the third side using compound inequality. Okay, so the simplest one is the first side plus the second side has to be greater than C. Okay, then hopefully you remember from geometry that you add the sides for one end of the spectrum and you subtract the sides for the other. So 8 minus 6, C's got to be greater than that, which means C has got to be greater than 2. So C has to be greater than 2, but less than 14. So you have a third side of 2.0001 and 13.999. You just can't have 14.